In this video, I want to talk about radian measure. So what is a radian? Well, radians give us another way to measure an angle. So you're used to using degrees to measure an angle. Now we're going to introduce these other things called radians. And we're going to abbreviate radian as rad, R-A-D, usually written in lowercase. Okay, so that's great, but what is a radian? Okay, well, circles, and if I have a circle centered at O, point O here, with a radius of R, then this angle right here is called a central angle. And I'll label that angle theta. And this distance right here, this arc length, I'll label that S. So from geometry, you remember that a central angle is an angle that is from the center of the circle here, and an arc formed by a central angle has the same measure as the central angle. So this arc, I'm going to let it equal the radius. So my radius of the circle R is the same length as my arc length. And it turns out that when you do this, theta is exactly equal to 1 radian. So in other words, a radian is the measure of that central angle when I have the arc length equal to the length of the radius. Okay, so that seems like it might work for a particular circle, but doesn't this definition depend on the radius of the circle? So if I change the radius, doesn't that change what a radian is? Well, not exactly. I mean, it ends up being a ratio. So here's a circle, okay, and we know that the circumference of a circle, C, is 2 pi r. Okay, 2 pi times the radius. And we know from before that when I had my arc length, and my arc length was equal to r, then the measure of that central angle was equal to 1 radian. Okay, so what about if I go all the way around the circle? So in other words, the circumference is 2 pi r, so what if I made my arc length 2 pi r? I went all the way around the circle. Well, then my central angle would be 2 pi radians. Kind of makes sense, right? So now, if I go all the way around the circle, that's 360 degrees. So that tells us that 360 degrees must be the same thing as 2 pi radians. Or if I divide both sides by 2, 180 degrees is equal to pi radians. And now I know how to go from degrees to radians. Okay, well that sounds great, but the big question, why? Why would we ever want to use radians? We're so used to using degrees. Wouldn't it make sense to just stick with degrees? It's familiar, and why bother even having some other method? Well, radians they kind of make sense for circles, because remember circles, you always think of pi. It would be kind of nice to get pi involved with circles, and so radian measure actually makes a little bit more sense. I mean, 360 degrees, it's kind of arbitrary. Why 360? At least with radians, it kind of makes sense, where the circumference is 2 pi r, so if you go all the way around the circle, that's 2 pi radians. Just makes sense. Another reason is that in calculus, some of the formulas you see, they look a little bit nicer when you use radians instead of degrees. So I know that doesn't help a whole lot right now, but in the future, if you do end up learning calculus, it would probably be better to have the formulas look a little bit nicer rather than having extra factors that you have to carry around.